My name is Marcelo Dantas, and I'm the curator of the exhibition Eclipse. The exhibition, shown at the Museum of Astronomy and Related Sciences, MAST, between May 2019 and May 2020, presented several perspectives on a fundamental moment of the 20th century. In May 1919, two English expeditions photographed a solar eclipse, one in Sobral, in the state of Ceará, Brazil, and another in the island of Príncipe, West Africa. The images from these epic journeys would confirm the validity of a new theory, which intended to understand the structure and evolution of the universe. The contemporary world was beginning. The first room of the exhibition takes the viewer on a journey through time, from the old conceptions about our place in the cosmos through the year 1687, when Isaac Newton published his theory of universal gravitation and the foundations of classical mechanics, which would allow to study the movement of bodies and their causes. The collection of images and interactive devices in this room are able to show the observer the clash of ideas that characterized the end of the 19th century, where Newtonian physics was the archetype of scientific reasoning and where theories appeared to explain phenomena that could not be understood in the logic of mass interaction. The theory of electric and magnetic fields, synthesized with brilliant simplicity by James Maxwell in 1862, suggested the unification of these two fields, from which the combined evolution in time emerged wave manifestations that allowed the propagation of energy through space without the presence of a material medium. Maxwell's electromagnetic theory questioned Newton's conception. According to his theory, not only light was a wave, but also was just one kind of wave among many of the same nature, different from each other only by their frequency. The declared incompatibility between these two views of natural phenomena, crowned with the success in practical applications at the beginning of the 20th century, highlighted the curiosity and creativity of many scientists of that time, including Albert Einstein, who in 1905 proposed as an innovative and challenging idea to save the apparent discrepancies between the theories of Newton and Maxwell, the electrodynamics of bodies in motion. The last panels of this room provide a first approach to the foundations of the general theory of relativity, Einstein's most revolutionary proposal, replacing the notion of gravity with an abstract geometric concept required more than mathematical elegance to convince men of the science at the time. In the new conception, the light ray from a distant star becomes curved in the vicinity of a massive body. Measuring this deflection could be a way to test Einstein's exotic theory. His communications with astronomers like Arthur Eddington made it possible to use the observation of a solar eclipse with this purpose. The second room places the visitor in the environment of observation instruments, campaign photos, and a place that would be immortalized by a single sunny morning in its history, the city of Sobral. The observational mission of the solar eclipse of May 29, 1919 was planned before the end of the war. Its execution depended on an armistice that was not arriving and the availability of resources to transport two teams of professionals from England to Brazil and to the island of Príncipe. In this room, the visitors learn about the relevant role played by the National Observatory of Rio de Janeiro, led by its director, Henrique Moriz, in the organization of this expedition to Ceará. The analysis of the photographic plates obtained in Sobral and in Príncipe Island allowed, on November 6, 1919, the presentation of convincing and favorable results to Einstein's theory by astronomers Eddington and Frank Dyson, director of the Greenwich Observatory. The success of this endeavor will create the media image that will accompany Einstein to this day. On one side, a dark room where the most significant equations of Einsteinian theories allowed the visitors to visually recognize the complex and elegant language with which Einstein intended to explain the universe. A curtain separates this room from another space where it is possible to simulate the audiovisual effects that involves a solar eclipse. The next room offers the visitors the possibility of an intuitive understanding of the notion of space-time curvature through a simple device made of flexible fabric and objects that deform its surface. More tangible approach to the phenomena explained by the general theory of relativity, such as gravitational waves, is realized in the last room. This room gives to any visitor, regardless of their knowledge of physics or mathematics, a cognitive experience with the most challenging theory about the structure of the universe that has changed forever the way we understand space and time. Our understanding of the universe 100 years after this episode is based on several pillars, among which are Einstein's theory, where the largest mass concentrations in the universe are studied. Astrophysics and cosmology researchers open new windows every day to study the most exotic forms of matter and energy, and the most distant objects and the most remote times in the history of the universe. Research in these areas brings us new and increasingly accurate information on billions of years of evolution. The visit to the exhibition Eclipse is a passage through the history of the evolution of our understanding of space and time, and the history of Brazilian science in one of its most symbolic moments.